Hello, Professor. Today I'm going to talk about pigeonhole principles application in maximization and minimization problem. And I want to use a story to tell the application. And the main character is called Dr. J. So first, in the first scenario, he wants to run the blood test among volunteers. And we know that humans have four kinds of blood: A, B, AB, and O. In order to match these two patients, the blood types must be the same, and therefore we have four pigeonholes, four plus, and then we treat them as four pigeonholes. Then we need 4 plus 1 equals to 5 pigeons to make sure that one hole must have at least 2 pigeons, and therefore Dr. J should select at least 5 patients. And then we want to analyze a far more complicated question here. So Dr. J has a pretty strange boss. The boss requires him to treat patients every day in 10 days. However, the number of the patients must be odd every day. So we define them as A1, A2 until A10. So the second requirement is that the difference between any two numbers must be different. So Dr. J is a pretty lazy guy, and then he wants to know that what's the minimum number that he has to treat, he has to meet in these 10 days. And then first we consider this question, and then we generalize the problem as n. So we consider n numbers, then we consider that A1, A2, and they are all odd numbers, and therefore AJ, AI, AJ must be an even number. And therefore the biggest value or among this value must satisfy the requirement that is bigger than 2 times n choose 2 equals to m1. And therefore we can get this relationship that and then we must you may think that why is an bigger or equal to 1 plus m times m plus 1? The reason is that a1 is a positive odd number, and then it must fulfill this relationship. So that's where we get this from. Therefore we get this, and then we go back to the question. Every single notation A1, A2, and then AN must fulfill this relationship. Therefore we sum them up, and then we can obtain a relationship which is 10 and 1 plus 2 times 3, and then we get 340. So that's the minimum number of patients that Dr. J has to meet. And that's all. Thank you.